So in my previous video, I loaded data from Major League Baseball into three data frames: GameLog, people, and teams. Now in this video, what I'm going to do is I'm going to conduct an exploratory data analysis on my GameLog data. I'm going to explore the data to see what data elements I have, and look at particular fields of interest, to look at the distribution of values within that, just so that I can understand the data that I have, so that I can start forming some research questions for this data. So the first thing that I'm going to do is I'm going to go ahead and set my working directory, and then load the library tidyverse. I'll be using some functions from the tidyverse library. All right, so that's all loaded. Now next, what I'm going to do is, in the future, I'm going to be conducting some predictive analysis. So I need to split my data up into training data and testing data. So I will be looking at the training data to be able to develop some models that I'm going to then apply, some of the predictive models that I can apply to my testing data. So I'm going to split the data up, that GameLog data. I'm going to split this up into one data frame of testing and one data frame of training, where 75% of the data is going to go into my training data frame and 25% of my data is going to go into the testing data frame. Now, there's two ways that I can do this, and this is really because of the type of data that I'm using. So these game logs, I have all the data, each game that took place since 1960 in this GameLog data frame. So we could look at this data as a collection of data that we can look at each individual attributes as just in of themselves, or we could also look at these as a season that unfolds in more of a common pattern from year to year. So if that's the case, then that really could be a time series data. So option one is I could treat this as time series data, and then I'm going to, if that's the case, I'm going to be looking at data from 2016 all the way through 2020. Now, in this case, I'm going to look at just one season. So I'm not going to take this as a time series approach, but just as a collection of data. So no time series considerations. So what I'm going to do is I'm going to take option two here in my code, and I'm going to take data from 2022, and I'm going to take that data and then split it up into training and testing. So again, training will be 75% of my data, testing will be 25% of the data. So first, let's look at the number of rows that I have for 2022. So I'm going to run that line, and I see that I have 2,430 rows of data. So that means in 2022, there were actually 2,430 games that took place during that season. So I have plenty of data to look at. So what I'm going to do is now that I know that I have enough data to look at, I'm going to pull the data from the GameLog data frame, and I'm going to create a new frame called season. So that season data frame will contain only those games, those rows from 2022 of my GameLog data frame. So I'm going to go ahead and run that. All right, that ran. And so now, as you can see, I have a new data frame called season. And as expected, that data frame has 2,430 rows, or 2,430 observation, with all 165 variables. All right, so now what I'm going to do is I'm going to take that season data, and I'm going to split that up into my training and my testing. So again, 75% of it is going to be pulled out and placed into a training data frame, and 25% of the rows are going to be placed into a testing data frame. So first I need to seed it, and then I can go ahead and pull the data into a temporary data frame called sample. And that is just a list. It's not a data frame. It's just a list of values. And then I can, from there, split the data into training and testing. And then I can go ahead and remove that list. That was just a temporary list to allow me to split the data. But that sequence of events allows me to take data from a data frame and then split it up into two separate training and testing data frames. So as you can see now, I have a data frame of training, which is 1,806 observations, and my test data frame is 624 observations. So roughly 25 and 75% of my sample data. All right, so now we're going to go to my training data frame, and we're going to take a look at that data frame, see what that looks like. So when I run this line, it's going to go ahead and open up my training data frame. And I can see this looks just like the previous video when I took at the GameLog data. This is the subset of the GameLog data. That is 75% of the records from the 2022 baseball season. All right, I'm going to close that. All right, so now let's take a look. Again, this is just data that's within that training data frame. Let's take a look at the length of each game. So after the 2022 season, Major League Baseball, I know that they were doing things to shorten the games. The games were getting too long. So let's take a look at how long those games were in 2022. So what was the longest game that took place that's in my training data set? And I can see that was 324 minutes. Now, what was the shortest game? I'm going to run the min command, and I can see the shortest game was 99 minutes. Well, what was my median? My median game was 185 minutes. And if I take a look at the average or the mean, if I'm rounding that to 0 so that I can compare that, I don't need to have that as a decimal. I just wanted that as a whole number. I can see that that was 187 minutes, which is very close to my median. So I would say it's probably going to be pretty a normal distribution. But let's take a look at that. So I'm going to create a plot where I'm going to do a bar plot in blue. And I'm going to take a look at the number of minutes and the number of games. So this is a distribution bar chart so that I can see how the length of the games were distributed across my training data. If I run that, then I can see over here, and I'm going to go ahead and zoom in on this. I'm going to click on the zoom button and maximize that. Now I can see exactly what I thought. It's a relatively normal distribution, and the median and mean were about 187. So it's in this this period right here. So now I can see what the number of minutes for a baseball game looks like. And there are some outliers, one in particular here, but we can see that it's a fairly normal distribution. All right, going to close that now. All right, so I see what the game data looks, or the minutes looks like. So next, let's take a look at the point differentials. So I'm interested to see by how much did the winning team win by. So I'm going to take a look at the home score and the visitor score. And so sometimes the home score is going to be lower than the visitor score, and I don't want to look at negative values. So I'm just looking at the difference between the two. So what I'm going to do is I'm going to take the absolute value of that difference. So I'm going to always get a positive value. So the largest differential between the home team and the visiting team. So in this case, the winning team won by 23 runs. That's the largest point differential in 2022. Now, the smallest, I would imagine, would be 1. And yes, it is. All right, and what was the median value? The median value was 3. And what was the mean? The mean rounded is also 3. So let's take a look at what that looks like. If I took a look at my distribution of point differentials, I'm going to do this in red this time. And if I hit enter here, let's take a look at this. And as expected, this is not going to be a normal distribution because we're not going to see, because we did the absolute value, so we're going to see only positive values. And expected, most games are relatively close, and it's really those large differentials are really outside the norm. So we can see here that many games, or most games, are just a 1-point differential. You can see that 2, 3, 4, and maybe up to 5 are somewhat common, and then after that we're seeing that they're less common. So this is not unusual, not what we would, agrees with what we expect to see. All right, so next we're going to take a look at the months. So do we see that certain months have longer games than others? So in this plot, we're going to take a look at the month and the number of minutes. So we're going to do a box plot for this. So our box plot's going to show us the range of values for each of the months. So when I run that, this is what it looks like. I'm going to maximize that. All right, so now I can see the month. This is the month number. So April, May, June, July, August, September, and October. And we can see the point difference, or the length in time. So the average length across them are pretty close, although it looks like maybe September has shorter games than October, probably fewer games in October during the regular season, so those are shorter as well. So we're seeing that there is a difference, but not a significant difference, or not a large difference. All right, so next we're going to take a look at the day of the week that's most common for the games, or at least in 2022, what days of the week were most common. So we're going to go ahead and plot that in green, and this will be a bar plot for each day of the week. And zoom in on this. And we can see here that Saturdays were quite common day of the week to have the baseball games. And that looks like Mondays and Tuesdays were less common, at least according to our training data set that we split out. All right. And now taking a look at night games compared to day games. So we do have a night game indicator. So let's see if night games were longer or shorter than day games. And we can see that doing this in a box plot, so we can see the range as well. And we can see they're relatively close, but we have a lot more outliers, so longer games than that at the tail end of our distribution at night compared to those during the day. So we can see that while the mean is pretty close, there are some outliers. So we're going to see some games that were lasting longer that were night games than those that were longer as a day game. All right, so now what we're going to do is in R, we can create a custom function. So I'm going to create a function. So I'm not going to use a function from one of the libraries. I'm going to be using a function that I'm going to create my own. So what I want to be able to do is update my data. I'm going to calculate the attendance for each game as a percentage of the largest attendance for the season. So I'm going to, again, this will be the largest attendance for either the training or the testing data. And I'm going to, because I want to figure out if this, for each game, was it highly attended or was it lowly attended game? And since I don't have maximum capacity for each of the ballparks for any given season, I'm going to just use my max value as a relative indicator of capacity. So here I'm going to build this function where it's going to go into either the training data or the testing data. It's going to figure out what the maximum attendance was, and then it's going to allow me to apply that data to both the training or the testing, whichever data frame I'm going to pass in. And it's going to then, for each row in that data frame, it's going to add a column that's going to be called crowd size, and that's going to be a percentage of that game's audience compared to the largest attendance game within that data set. So I'm going to go ahead and create this function, And there we go. We can see the how full function has been created, and we create it by calling this as a function, and I'm passing in a data frame, and then the function's going to work by creating a data frame called max attendance. It's going to go ahead and it's going to go to that GameLog data frame, and it's going to group by each park, and it's going to find the largest crowd size, and then it's going to create a separate data frame called max attendance, and now it's going to merge, do a left join between that max attendance and the data frame I want to look at. And it's going to do that, and as a result, it's going to create a new column called crowd size, and that's going to be the max attendance, actually the attendance of that game divided by the largest crowd size, and it's going to just look at a 2 decimal value for that. So now if I take that function that I just ran, and if I run this against my training data set, it should now have created a new variable, a new value. In the training, I see now I have 167 variables. So let's open that up and see what this looks like. And scroll, I'm going to go all the way to the end and scroll to the end. And there we go. So it actually added 2 fields. One was the largest crowd, so I can see the maximum crowd size. And then I can see that for this game, the percent of that crowd size that we had. So this allows me to then calculate the percent full or percent capacity, the relative capacity for that given game. All right, and so then what I can do is I can run that against my testing data. So this function set up so that I can pass in the data frame that I want to look at, and then it's going to go ahead and create those 2 variables. And if I run this against my test data frame, I can see now that's 167 variables. And if I look at the very end of that, I can see, there we go, I've got my largest crowd and my crowd size. All right, and so what I can do now is I can do the same similar evaluation of my testing data that I conducted on my training data, and then just note any differences in my observations. I would imagine, since this is a random selection from a single season, we shouldn't see significant differences. I think the results, the plots that I created for my training data will look very similar to my testing data. But what I will do is I could go through the rest of this script and run that, and then be able to compare the differences. And I think if we were taking a look at different seasons for my training versus testing, we would see different results. But since this is 2 subsets from the same season that are randomly selected, there should not be much of a difference. So with this exploratory data analysis, I've seen different variables, looking at their range of values, and noticing if they're a normal distribution or not. I saw that I wanted to figure out the percent of capacity, so I created a function to calculate that for me. And all this will be useful as I start developing research questions on my data and then start to conduct some analysis. So I hope this helps you understand how to do an exploratory data analysis on your data. And this was just one set of some exploration, but every exploratory data analysis is going to look different, and it's hard to define up front exactly what you want to do. You're going to be finding new questions that you want to ask as you conduct your exploratory data analysis. So this R script allows me to re-execute it and to show how I conducted the analysis. And the plots help provide some visualization so I can visually inspect what the data looks like. So give this a shot and see how well it works for you.